This is the Cloud Security Today podcast, where leaders learn how to get cloud security done. And now your host, Matt Chiodi.
Software supply chain security. When you hear that term, what comes to mind? I know for me, the first thing that I think about is what happened with the SolarWinds attack a few years ago. And so in this episode, what I wanted to do was bring on an expert, someone who is actually very much involved, has firsthand experience with software supply chain security issues. And I could think of no one better than Varun Badhwar. Now, Varun is a good friend. I worked for him for a couple years back at RedLock, also at Palo Alto Networks. But the thing that's, I think, unique about Varun, and he'll talk about this during the interview, is that when he was at Palo Alto Networks, he managed a team of over 400 software engineers. So the whole concept of software supply chain security is something that Varun knows really well. So I think you're really going to enjoy this episode. It's actually one of the shorter ones, but as usual, Varun is succinct, on point, and really doesn't waste time answering questions with a lot of flowery words. So get your pens ready, take some notes, and enjoy today's episode. Varun, thanks for coming on the show.
Yeah, thanks for having me here. I'm excited to chat about all the great things we have lined up.
Awesome. So let's just start off with just a quick background. And specifically, we're going to be talking about software supply chain security. Tell me a little bit about your background and what's your specific experience with software supply chain?
Sure. So I've been building companies for the past 13 years in cybersecurity. Prior to that, I was a practitioner myself at Salesforce.com. I was fortunate enough to be in the cloud security space as a practitioner before most people could spell cloud security. I'm talking back 2007, 2008. And I've just kind of been privileged and lucky to be just ahead of the curve in a number of areas. Cloud happened to be one of those. Most notably, prior to starting Endor Labs, I was the founder and CEO of RedLock, which is the leader in cloud security posture management. Got acquired by Palo Alto Networks in 2018. Where I then went on to create Prisma Cloud for Palo Alto Networks. You were there with me side by side as we did this. So it was an amazing journey.
It was.
But speaking of how I got into software supply chain security I am by no means a PhD in this space. I'm just a person who was on the receiving end of this problem. So back at Palo Alto Networks, when SolarWinds happened, obviously the board and every company management team was pretty spooked and wanted to make sure that, we had better handle and governance around our own supply chains. And I think the reality, Matt, was you come to realize that as an industry, we have never really foreseen the threat the way it affected all of us. And what I mean by that is you talk to most CISOs, they would talk about the big IP risk being a contractor leaving the building with kind of a USB drive with the source code. But we never thought about our source code being weaponized against our users, our customers. And, as you start thinking about that problem, you just start looking into your software development practices. And the biggest recognition was over 80% of code was not code my developers were writing, but were borrowing from complete strangers on the internet. These are strangers, but we can't even really call them suppliers, right? I mean, these are strangers. They owe us nothing. We have no contractual obligations with. We don't know where they live. We don't know their motivations. And, the first thing we all think about is, let's get software composition analysis tools working. And I know we're going to talk about more details. But for me, firsthand, when I ran these types of tools for my product area with 400 engineers on my team, it was reporting tens of thousands of vulnerabilities, which as we were trying to go, investigate, it would turn out 7, 8 out of 10 were false or were just not applicable to the way we were using that open source software. And, at that point, I looked at my peers in the industry and I said, are we crazy or is everybody facing similar challenges? And everybody was. And I think that was where I said, okay, it's my calling to go solve this problem in a much more comprehensive, efficient way than the way the industry has been so far.
So if I'm a listener in my company, and I think all companies at this point are software companies, doesn't matter what you're doing, you're creating software or you've outsourced it to somebody to create for you. How do organizations go about identifying and mitigating this risk, right? Because depending upon the size of the company and what they do, this is really complicated and complex. How do you just start that process of identifying and mitigating these risks?
Yeah, Matt, great question. But before we get that, I find like not everybody has the same level of understanding of how open source works. So let me maybe just give a 101 preamble on this. How does all of this come together in your environment? First and foremost, there's 47 million packages and versions out there in the open source ecosystem. There's over 3 trillion annual downloads being performed by your developers in your companies, okay? So the magnitude and scale of this problem is massive. Now, second piece is, how do these, there's 3 layers here in an application. There is your code. Think of this as the assembly line in your manufacturing facility. Within this assembly line, your developers are bringing in dependencies or open source packages directly. What direct dependencies are things you have intentionally chosen to select and bring into your environment. But then there's a bigger problem, because for each one of those things that your developer wants to bring in, on average, it comes with 77 what's called transitive dependencies. So just think for a moment here. You thought you were bringing in X. X brings in 77 friends to your party, uninvited. But they're there, they're at your house. And, if you're worried about COVID spread, guess what? They can spread COVID as much as your first friend can.
Right.
And so from an inventorying perspective itself, like to your question, I think the biggest problem has been we haven't even recognized the magnitude of this problem and just how this sprawl happens. I think once you start getting an appreciation of that, then obviously the second question comes up. How do I do this in a manner that is efficient and effective? Because let's be honest, developers are winning the battle in innovation and time to market. Like if you put blockers, they will win. And what is the evidence behind that? Well, 5 years ago, large enterprises were blocking access to GitHub. Like your developers couldn't even go out and get code. Today, we've pivoted to the other extreme, which is you can download anything off the internet. And, there are paper-based kind of governance rules that say you should do X or you should do Y. There are still a handful of companies that require engineers to log tickets and wait for weeks to get approval against those, but those programs don't work. Now, let's also draw a parallel here, Matt, to third-party risk, right? What do we do when a commercial vendor is selling a software? Our procurement team will not let a vendor get through until we understand their SOC 2, their pen test reports, their questionnaires. We're basically evaluating security and operational risk. In open source, we're doing nothing, even though we have zero contractual obligations. So where I think we as an industry need to evolve to is having certain guardrails, training wheels, basically, which is we can't block GitHub access, but we also can't have ticketing-based approval mechanisms for developers to wait for things to come in. You need automation. Somebody put it well, I was speaking to yesterday, you need a Carfax for open source software. You need a mechanism in which you can evaluate, okay, who are the people behind this project? How good is their code quality? Can I trust that they will maintain it? Is it secure? We just need a whole mechanism around that works at scale, not requiring the army of developers that the 1% of companies like Google and Microsoft have to build all of that infrastructure themselves.
So, and I appreciate that background. I know that the approach for some companies I have been at in the past, there were some individuals in the organization that just say, well, we're not going to use open source, right? Which I think is a losing proposition, but is that even possible? Is it even possible to build a commercial tool of any type without using open source?
It is not. You will not be viable. You will not be in business. If your competitors are shipping something in 3 months and you're taking 3 years to ship it because you want to build everything yourself, it's not happening, right? Your product is dead on arrival. So, the other piece is commonly people think, oh, it must be just the software vendors and the SaaS companies using a lot of open source. That's actually factually incorrect. Every company is a development company. If you're a retailer, you're building mobile apps, you're building your own self-checkout applications and other things. If you're a bank, you're building applications. We are finding everybody from automotive to manufacturing, all of kind of across verticals have this problem. In fact, believe it or not, most people are surprised, but one of the most forward-leaning organizations in starting to enforce a lot of this U.S. government regulation around software bill of materials and more visibility and transparency is the FDA. The FDA is now mandating any medtech company that's shipping devices or software to start submitting those SBOMs. So kind of the writing's on the wall. It affects every business. It affects every industry, and you just can't live without it. Now, the question is, do you want to kind of have a home without surveillance cameras and alarms and monitors and guard dogs, or do you want to do something about it? Because guess what? The bad actors have figured out that this is a weak spot. And every single month, we find thousands and thousands of malicious open source packages being deployed into these ecosystems to try to get your well-intentioned developers who are trying to move fast to basically be compromised.
So eliminating open source isn't going to work because it's so just a part of how software is developed. How do organizations go about identifying and starting to mitigate this risk? Like, where do they start? If I'm an organization and maybe I've made investments in, I don't know, some tools in the past, but I really don't have a strategy, where should they start?
Great question. So the most common alternative people have used so far to try to solve this problem is software composition analysis, or SCA tools. It's important to understand where these tools started out their journey from. They all started about a decade ago with license compliance, right? Legal teams wanted to understand exposure to legal risk based on the components you were using. So the mechanism to scan and the technology behind it was pretty dated. And eventually we said, okay, we need to do vulnerability compliance in organizations. So the same technology was used to then start doing vulnerability scanning. And that has led to tremendous wastage of engineering cycles, because what you will find these tools end up doing is causing a lot more noise than there's value. So how do you solve all of this? Let's kind of get through the principles first. One, this has to be integrated into the developer workflow. Asking developers to go outside of their workflow to go find things and understand if they can use it doesn't work. So step one, in the IDE, that's where your developers are bringing in open source software, right? They're doing a command like npm install, React. Okay. You need to be in that workflow to recognize what somebody's bringing in. 2, do that assessment, that Carfax scanning for them and say, wait a minute, you're trying to bring in this piece of software. Here's everything we understand about its security and operational risk, the human risk, the code quality risk, right? Provide those metrics to your developer, because I promise you, if the developer understood that information, they would likely make better choices themselves, right? Today, not having that information means they're trying to do their own research. They're looking at things like GitHub stars for open source project. I could buy 1,000 GitHub stars for $64 today on the internet. So those aren't real metrics. What you're truly trying to do is identify in the developer workflow the potential problems, give them that feedback. Okay, now let's say at that point they choose to ignore you. Well, guess what? They've got to push that code into a source control system, right? A GitHub or a GitLab. Well, if you integrate it into the whole pipeline, as they're trying to check in this imported package from the open source ecosystem into your code repository, is where you can actually enforce policy. In the example of a policy, you can say, I will not let you bring in unmaintained open source software into my enterprise, or I will not let you bring in something that has known vulnerabilities that have been open for over 6 months and not being fixed in a particular package. Or I will not let you bring in something that doesn't even have a CI pipeline through which they ship updates, because for me, getting kind of provenance and understanding of risk will be difficult. So those policies can then be enforced in the CI/CD pipeline. You can break builds, you can warn developers, you can report it to the security teams. The whole idea being automation first, and then if you need to triage for further investigation, you can. And ultimately, all of this data surfaces in a centralized inventory, which now, across a typical enterprise that has thousands of code repositories, can tell you an aggregated view across all of the different open source components being used, not just the direct ones, all the way down to the transitive ones. But Matt, more importantly, not just telling you what all has been imported, but specifically down to the line of code of how it's being consumed by your developers. Because that is the single biggest way you can get to prioritization and elimination of a lot of vulnerability noise and general feedback that slows developers down.
So obviously, when you're talking about software development, there's multiple different tools, multiple different teams that are involved. Let's talk a little bit about this from a strategy level. Let's talk about collaboration between different stakeholders. And by stakeholders, it could be those that are both inside the organization as well as those on the outside. So the software vendors themselves, government agencies. I know you mentioned SBOM, so maybe let's talk about that a little bit right there. But how does what's happening at the government level, because they've been talking about the software bill of materials for a while. So actually, let's go down the rabbit hole on that a little bit. Where does the SBOM come in with software supply chain security? Is it a panacea? Is it the silver bullet?
Yeah.
Help me understand that.
It's the start of a conversation, and what I often call an SBOM is a means to an end. Ultimately, we're all hoping and praying that software bills of materials will help us secure our open source usage around that. But let's be real. It's an artifact. Producing an artifact doesn't solve a problem, right? So to me, if you want to build this left to right kind of just picture in your mind, the left-hand side is when a developer introduced some new open source code. Somewhere in the middle, they developed it, they customized it, they tested it, integrated it, put it in a container, they shipped it. On that far right-hand side, when you're shipping it, somebody produces an SBOM. Guess what you can do at that point? Nothing. You can produce an artifact, but you can't change the outcome, right? The outcome is if something bad went in on the left-hand side, it's showing up on your SBOM, right? The other piece I kind of commonly touch upon here is like everybody loves to talk about the food label analogy, so let's touch on that. Okay, when FDA said we're going to put food labels on, what did all the manufacturers do? They slapped on the labels, but guess what? If the ingredients going into your product now were not good,
right,
you were embarrassed and you were self-aware that you need to go fix it. And you need to replace it with healthier, more nutritious ingredients, things, you don't want 10 grams of trans fat, for example, so figure out a way to kind of reduce that. And so I think this is why I go SBOM is a means to an end, because once you start having the conversation to air your dirty laundry, expose your lack of maturity and governance of processes for how your organization uses open source software, and now your customer sees that artifact, it's going to force you to kind of have that life cycle approach for managing open source software. So that's one. Second question you asked is, who are the stakeholders internally? Well, there's two main organizations. There's the security team that's obviously kind of driving policy, driving requirements. And then there's the engineering organization that ultimately has to change behaviors. And commonly you find a lot of tension between these two organizations. I wrote about this on LinkedIn a couple of days ago on Valentine's Day. Tension a lot between engineers and security professionals. Remember, engineering KPIs are on speed, time to market for delivering features. Security is risk management. These are orthogonal. So how do you bring these together? Well, let's kind of find the common ground. The common ground is open source software, if not managed correctly, can add a lot of headache for engineering teams as well. The maintenance of it, the upkeep of it, it's not automated. There's no customer success team with open source software telling you how and when to update it. So you as an engineering organization that's consuming it now has to manage and maintain it. So there's certain common ground there where you want to nurture all of this. Security wants to make sure you're on the right version, you're using the right level of software, compatibility, and all. So we're looking at those overlapping spaces, and what we're finding in most of our customer engagement is stakeholders are both. There's somebody from the engineering platform teams, or more, the more snazzier name for this is engineering productivity teams in newer organizations. Those teams working closely with the application and product security teams to say, how do we solve this end-to-end problem? Because, okay, somebody needs an SBOM on the product team side. CISO needs to manage risk. Engineers need to bring in more open source software and be more effective. Find the common ground, and let's find a centralized mechanism to solve dependency management end-to-end.
Prisma Cloud secures infrastructure, applications, data, and entitlements across the world's largest clouds, all from a single unified solution. With a combination of cloud service provider APIs and a unified agent framework, users gain unmatched visibility and protection. Prisma Cloud also integrates with any continuous integration and continuous delivery workflow to secure cloud infrastructure and applications early in development. You can scan infrastructure as code templates, container images, serverless functions, and more while gaining powerful, full-stack runtime protection. This is unified security for DevOps and security teams. To find out more, go to prismacloud.io. We talked about a little bit about this, but are there any best practices or industry standards that organizations should follow to improve the quality of their software supply chain?
Look, it's all emerging, right? There's a lot happening every single week. So you have Google has a standard called SALSA, SLSA. You've got NIST that has a framework around this. You have WASP that has a framework around it. Frameworks are a dime a dozen now. I think the question will be, it remains to be seen how these will be adopted. CIS now has its own frameworks and checks. Unfortunately, though, as we have seen in past life, the first thing that drives a lot of security shifts is compliance. And I think for organizations that are selling to anybody in the government, trying to prepare themselves for what I call the SBOM movement is probably where we're seeing the most activity and action. We will be launching in a couple of weeks' time some very interesting research on this topic. I won't share much more than saying, look out on March 1st for an announcement on the Endor Labs side on how you can actually think about these risks and prioritize these risks. It's peer-reviewed by dozens of CISOs, so it's coming shortly. But I'd say, look, there's certain things that are fundamental, Matt. Like, you don't need a standard to align with, like visibility, inventory of your software components. These are foundational controls. Get those things in order. Get your vulnerability management program to be more efficient, because right now you're piling up more vulnerabilities than you can fix. So get your basics together, and then you'll be in a much better shape to manage and maneuver through a lot of the emerging challenges. I think where organizations are is there's a bit of inertia. You just can't get out of your own way with the way you're doing, using existing tools and doing vulnerability management. So I think we just need to get past that. Net it out. There's lots of standards. Pick a favorite one. But at the end of the day, it's not rocket science. It's visibility. It's guardrails to prevent bad things from coming in. It's detection and response measures for the next Log4j incident, better preparedness. So you can find these things, resolve them faster. And the fourth piece is really around compliance. So summing it up, select, secure, maintain, comply. That's all you got to focus on.
You touched on this a little bit earlier, but I shouldn't say most, but a good bit of software development is now being done natively in the cloud. So all the big ones that we all know about. So is there a gap in the security tools and services that's being offered by the cloud providers when it comes to the software supply chain?
This is an interesting question, because I think cloud platform providers see things when you're ready to deploy them. Right? If you think about a lot of it, the cycle starts with a developer pulling down code locally on their laptop as they're investigating things. They write some of that software. Then probably the next checkpoint is the GitLab platforms of the world. And then ultimately it's the cloud platform providers. So I think unlike the cloud security posture management market and cloud workload protection, where you can say, well, how much a cloud provider is going to do? I think really the question here is, what is GitHub and GitLab, as kind of where majority of source code lives, doing about this problem? And we found a couple of areas where they've really made good investments, honestly speaking. The first one is first party code. So for that 20% of your code that you are writing, your developers are writing, the legacy way to do scanning against that was SaaS products like VeraCode and Fortify and Checkmarks, but they were extremely noisy. They weren't integrated into the development process. And so a lot of those use cases are now best handled by GitHub through advanced security and GitLab through their premium offerings. So like everything else, this is a shared responsibility, even with open source code. The other piece I would caution the listeners on, and this is a fallacy that we all fall into the trap, is the maintainers of this open source project are volunteers. Please remember that. They owe you nothing. During Log4j, Matt, there are so many companies sending the maintainers of Log4j spreadsheets asking them to complete it. Why? They don't owe you anything. You don't pay them $1.
Right.
Yesterday I published about a maintainer who runs a particular JavaScript project with 250 million downloads a month. He can barely pay his bills. He's a single maintainer, lives out of Russia. The entire internet infrastructure from Netflix to Amazon depends on him. And people aren't willing to pay him. The guy can barely make $3,000 a month through donations, and he's trying to feed a family and kids. So take on the responsibility. It is yours as a consumer of software. Set aside budgets for open source programs. We are starting to see more progress being made with GitHub, GitLab, and the others. But I think by the time it gets to your infra deployments in the cloud, it's too late.
That gentleman that you're talking about is making $3,000 a month. Sounds like a perfect target for some type of espionage. We'll leave it at that. But when someone's that influential and there's a potential economic motivation, it sounds like the perfect pathway for some type of espionage. So hopefully people start to donate. Not to freak
out your audiences, and not to freak out your audiences, 2 more pieces of information there. He lives in Russia and he's been in jail for 10 months in the last 3 years. Your team still use that open source. Did you know that? You had no way to evaluate it.
I think we
need to get better at the industry.
You just made a bunch of security people have to do a lot of work after they hear this. So, tell us a little bit about Endor Labs. Like, how are you approaching this? What makes your approach unique compared to some of the others in the market, like a Checkmarx or a Sneak?
Yeah, great. Our focus is really, like I said, this is a pain I felt firsthand. So we took a very user-centric approach to say, what are the engineering? What are the problems the engineering teams are facing? What are the problems the security teams are facing? And really we bottomed out on 3 things that needed to be solved. One is the alert noise problem. The SCA tools generate far too many alerts. And the reason they do that is they're very coarse-grained in their analysis. So to just be a little bit more technical for a minute, the way all of the SCA market works is they scan your manifest file. The manifest file may be a BOM XML file, a package.json file. See, I'm getting smart on software supply chain.
You are, man. You sound like you actually write code.
I do. These files are basically directory listings of anything being imported. So I know you may be importing it into your source code, but I have no idea how you use it. So let's say you imported the AWS SDK, right? Great open source. Everybody needs it for cloud applications. Now that SDK comprises code for hundreds of different services of AWS. For my application, I'm probably using 2 services. So guess what? The only things I care about is tracking what parts of the AWS SDK library is my developer using, and of those 2 parts, what other dependencies transitively get called. And by having that knowledge of that dependency graph to that level of fidelity, now I will only bother you when there's vulnerability, security issues related to the pieces of code you actually use, not guilt by association. So that's one. The second piece, and by the way, that is almost rocket science. It is we have 7 PhDs and other smart engineers really working on this problem of building these call graphs at scale to understand that. So that's one. The second is the Carfax problem. There's 47 million packages. Your developer may want to use anything tomorrow morning. How do I get the analytics and metrics of the different things related to the humans, to the code, security, to quality, and present them scalably? So there's a pretty sophisticated infrastructure that does that at scale and provides those findings to you. And, most of the existing tooling focuses on just 2 things, and they're both late indicators: license risk and vulnerability risk. And they miss everything else. That would be an early signal, like the signals I just told you about. Right. Like this package with 250 million downloads and somebody who's starved, probably something you should be aware of as a potential risk if it's running your critical application. And the last piece is, what are CVs? What are vulnerabilities? Vulnerabilities are typically well-intentioned developers that made coding mistakes that are now surfaced publicly, and now you track them in their national vulnerability database. That's what your SCA tools do. There is now thousands and thousands of malicious intention people putting malicious packages. These are not accidental coding errors. They are knowingly malicious packages available in the ecosystem for your developers to download. They don't show up in the CVE database. How do you detect those? How do you prevent those from coming into your environment? So, those are probably the 3 main areas we focus on. And as I told you, we had to find the commonality between engineering and security. And one of the big problems was it's great for security tools to tell you have a problem, but engineers find it very difficult to update open source software. So the fourth competitive advantage we have is we actually help engineering teams with improving their application resiliency by actually looking at how they can further optimize all this open source code, maintain it, update it, remove it when necessary, to keep their applications running well.
What have you found to be the best way to incentivize engineering teams to actually use a security tool, whether it's Endor or for that matter, any type of software or tool? Because like you said, if you try to force somebody outside of their normal process, that's going to be usually something they push back on. And usually, like you said, there's this whole understanding that, hey, these security tools are going to be super noisy. They're going to create a lot of work for me. What have you found to be the best way to incentivize these teams? Because, I know it's in classic insecurity that like developers are always the problem, but what have you seen the right way to actually make it so if someone makes an investment in a tool like Endor, how do they make it so it's actually used and not resisted?
Well, I think we're seeing a couple of paradigms shift. One, I think it's very rare to see a security team exclusively evaluate and purchase a security product today, where they don't have the engineering team involved in the decision-making process, in the evaluation process. So one is, how do you delight not just the security people who are paying the bill, but how do you delight the users? Nobody wants more shelfware security products. The second piece is, can you build a security product that not only doesn't suck? So there's been 3 generations of security tools, right? There's been the good old meaty security tools that absolutely suck. Then there's been the next generation where they said, okay, let's build security tools that don't suck, right? And I would give Sneak as an example of a product that for the last 5 years has had that perception of, look, it's a security tool. It doesn't suck. It's probably the least sucky security tool out there. And then there's the third vector where I think a lot of companies now need to be, which is, how am I not just a security tool that doesn't suck, but how do I actually enable developers in their own workflow? Meaning it's not just about security, but it's about productivity enhancement beyond security. And I think where Endor has been really focused, and our teams and our product and engineering teams have really done a good job, is thinking about that life cycle. Don't just find me security problems, find me potential operational problems in my code. How are you going to make sure that I don't get paged at 3 a.m. one of these days because my application went down due to incompatibility of some open source software, right? That could be a bug unrelated to security, but it did bring it out of my application. So I think for us, it's really pushing the baton on that piece of go beyond security. How do you actually enable developers so they're not just using it to get security teams off their back, but they're using it because they are getting supercharged in doing their day-to-day jobs.
Varun, this has been a fascinating conversation. Is there anything that I maybe should have asked you that you wanted to comment on?
No, I think we've covered a lot, Matt. A couple of things that thematically we've touched on is, one is, I think a lot of the industry is still trying to understand and quantify what are these next-gen supply chain attack vectors, what is important. We have produced some pretty good research on this space. It's not salesy content, but if people want to go to endorlabs.com and they click on Risk Explorer, it's a very interactive way to understand these emerging risks that we talked about that go beyond vulnerabilities. So I would point your audience to that. And I think if there's one thing we all as an industry need to kind of step up on is, hey, the attackers have figured out our weaknesses on the supply chain. And I think we are taking far too long as an industry to kind of turn our ship towards the direction we need to go. And like it or not, this is one of those rare times where the U.S. government is regulating ahead of the industry being ready for it. Normally, regulation follows big paradigm shifts and the industry adoption. This is the opposite case. So I think we all need to kind of wake up, get to work, and start understanding how we can better secure our supply chains. But other than that, it was great to be here and chat up that with you again on that.
Awesome. Well, what's the best way for our listeners to connect with you? Maybe they've got questions. Maybe you've scared them with the story of the $3,000 a month Russian who's touching 250,000 or 250 million downloads per month. What's the best way for listeners to get in contact with you?
Look, if you want to learn more about the space, check out endorlabs.com. Personally, I love to engage with the community. Hit me on LinkedIn. Follow me, Varun Badhwar, and happy to chat more and brainstorm on ways to make our supply chains more secure.
I love it. Well, Varun, thanks for coming on the show. It's been great.
Thank you.
Thank you for joining us for today's episode. To find out more, please visit us at cloudsecuritytoday.com.